In 1962, President John F. Kennedy shook the world with a single declaration at Rice University.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
That sentence became a symbol of America's spirit of conquest, the courage to set impossible goals and the will to achieve them at any cost. More than 60 years later, the name John F. Kennedy is carved once again, this time on a marvel of steel and nuclear power. USS John F. Kennedy, CVN-79, America's second Ford-class nuclear supercarrier, a $13 billion giant, a new icon of America's determination to dominate the seas of the 21st century. But what draws the world's attention is not only its 100,000-ton displacement, nor its state-of-the-art EMALS electromagnetic launch system. It's a far bolder question. Could the Kennedy be the first carrier ever built with the potential to launch the sixth-generation fighter of the future? While China and Russia pour resources into hypersonic missiles and stealth drones, the United States is betting on a different formula: the unmatched power of the Ford-class supercarrier, paired with the dawn of the sixth-generation fighter program. If the Kennedy can truly deploy this next generation of aircraft, it will become America's strategic springboard to command the skies and rule the oceans. For more than a century, no weapon has shaped naval warfare like the aircraft carrier, since Japan launched the Hosho in 1922. The world's first purpose-built carrier, the nature of sea warfare has never been the same. During World War II, the carrier quickly eclipsed the battleship as the ultimate weapon. At the Battle of Midway in 1942, within just a few days, 4 Japanese carriers were sunk, turning the tide of the Pacific War. From that moment on, the aircraft carrier became the centerpiece of American power. Through the Cold War, it served as a tool of deterrence, ever present in every hotspot, from Europe to the Middle East and across the Asia-Pacific. After the Cold War, the carrier remained the spearhead. From the Gulf War to Afghanistan, it's no coincidence that whenever an international crisis erupts, the first question is always, where is the nearest US aircraft carrier? The secret to its dominance lies in one word: adaptation. Each generation of carriers was designed around the aircraft it launched. In the 1940s, carriers carried propeller-driven fighters, the Wildcat and Dauntless. By the 1960s, their decks had to endure the thunder of jet aircraft like the F-4 Phantom. In the 1980s, the Nimitz class was built for the F-14 Tomcat, and later the Fa-18 Hornet. And in the 21st century, the Ford class arrived, built not only for the F-35C Lightning II, America's first carrier-based stealth fighter, but also to pave the way for unmanned aircraft and the generations of warplanes yet to come. Ford class, the leap beyond Nimitz. Since the first Nimitz-class carrier entered service in 1975, these massive floating airfields have stood as icons of American naval power. With a displacement of 100,000 tons and the capacity to carry up to 90 aircraft, the Nimitz dominated the seas for nearly half a century. But as the 21st century began, its limits became clear. Operating costs soared with nearly 5,000 crew members on board. The steam catapult system was bulky, maintenance-heavy, and hard on aircraft, and the ships lacked the electrical power needed for next-generation technologies. In response, the US Navy conceived a new class of supercarrier, the Gerald R. Ford class. The first ship, USS Gerald R. Ford, CVN-78, was laid down in 2009, launched in 2013, and commissioned in 2017. With a construction cost of about $12.8 billion, plus another $4.7 billion in research and development, it became the most expensive warship ever built, and a platform for revolutionary innovation. The Ford class is powered by 2 next-generation A-1B nuclear reactors, delivering vastly greater electrical reserves than the Nimitz. Its EMALS, Electromagnetic Aircraft Launch System, replaces steam catapults. It launches aircraft more smoothly, with less stress on airframes and is designed to boost sortie rates by roughly 30%. The AAG, Advanced Arresting Gear, provides flexible digital control for recovery, capable of catching everything from unmanned drones to heavy strike fighters. Electromagnetic weapons elevators move munitions faster from magazine to flight deck, though early versions faced reliability issues. The Ford also introduced the dual-band radar, merging X and S-band arrays for integrated detection. And thanks to advanced automation, the crew was reduced to around 4,600 sailors, nearly 10% fewer than a Nimitz. Together, these breakthroughs prove one thing: the Ford class is not an upgrade, it's a revolution. A foundation for America's carrier power in the decades to come. Upgrades aboard the USS John F. Kennedy. The Kennedy, second of the Ford-class supercarriers, carrying the same colossal figures that made its predecessor legendary. A full load displacement of about 100,000 tons, a length of more than 1,106 feet, and a flight deck nearly 256 feet wide. It isn't larger than her sister, the Ford, but in that very similarity lies the foundation for critical improvements. The Kennedy doesn't flaunt raw size. Its power comes from precision, from how every square foot of the flight deck has been optimized. With emails, AAG, AWE weapons elevators, and the EASR radar, this ship promises to turn its deck into a relentless war machine. Faster launches, smoother recoveries, seamless refueling and rearming, an unbroken rhythm of combat operations. Its design philosophy is clear. True power doesn't come from building bigger. It comes from extracting more performance from the same hull. In modern warfare, where every minute on deck can decide the battle, the Kennedy stands as a declaration. Victory lies in tempo, in turning a floating airfield into a machine of war that never rests. At the heart of the Kennedy beats the A-1B nuclear reactor system, a dramatic leap beyond the A-4W reactors of the Nimitz class. While a Nimitz produces about 550 megawatts, the Kennedy's twin A-1B reactors deliver up to 700 megawatts, more than 25% greater power. That energy drives the ship beyond 30 knots for sustained periods, while feeding every combat and life support system on board. Compared to the A-4W, the A-1B offers 30% higher thermal efficiency, 25% less volume, and nearly 20% less weight. This frees up valuable internal space for storage, workshops, and auxiliary systems, what engineers call strategic space. Another advantage: a 25-year refueling cycle covering nearly the ship's entire service life, reducing downtime and cutting operating costs. The immense electrical output of the A-1B powers more than propulsion. It fuels the technologies of 21st century naval warfare. Emails, AAG, high-power phased array radars, and even directed energy weapons. The A-1B isn't just a stronger reactor, it transforms the Kennedy into a true floating power station, a warship built to meet the demands of modern combat. One of its most revolutionary systems is EMAIL's the Electromagnetic Aircraft Launch System. Replacing the steam catapults that ruled carrier aviation for over half a century, EMAIL's uses linear induction motors to generate massive electromagnetic force, hurling aircraft from zero to takeoff speed in seconds. Compared to steam launchers, EMAIL's offers three decisive advantages. It eliminates bulky boilers, freeing weight and space. It provides smoother acceleration, reducing airframe stress. And by design, it can raise daily sortie rates by about 30% over Nimitz-class carriers. In high-intensity campaigns, that tempo can decide victory. In practice, EMAIL's is still being refined. Engineers continue to improve its reliability and control systems to meet the Navy's exacting standards. Even so, when first deployed on the Ford, the EMAIL's system faced serious growing pains. Its reliability fell short of expectations. Reports showed failures occurring after only a few dozen launches, a flaw that drew sharp criticism in the program's early years. On the Kennedy, engineers are refining the system, using lessons learned from the Ford. They're strengthening materials, upgrading control software, and fine-tuning launch forces to match the unique weight and performance of each aircraft. Working alongside emails is the AAG, Advanced Arresting Gear. It replaces the Nimitz-class hydraulic arresting system with a modern electric turbine design. The old hydraulic gear was dependable but rigid, ill-suited for aircraft with vastly different weights. AAG solves that problem. For lightweight UAVs, it eases the stop to prevent frame damage. For heavy strike fighters, it absorbs massive kinetic energy within a short distance, ensuring safe recoveries every time. Yet during early trials aboard the Ford, AAG also struggled with mechanical failures that raised doubts about its reliability. Aboard the Kennedy, those lessons have been applied. Mechanical durability, electronic controls, and software logic have all been re-engineered to handle a wider range of landing scenarios. If successful, the combination of emails and AAG will mark a complete transformation. From launch to landing, aircraft will operate more safely, more efficiently, and with far less wear and tear than ever before. This synergy is what allows the Kennedy to sustain high-intensity flight operations across multiple aircraft types, a leap in tempo no Nimitz-class carrier could match. Another key upgrade aboard the Kennedy is the AWE, Advanced Weapons Elevator. It replaces the traditional hydraulic lifts of the Nimitz class. The old elevators were steady but slow, a bottleneck during high-tempo missions. The new AWE system uses electromagnetic motors to move bombs, missiles, and ammunition quickly and precisely from deep magazines to the flight deck. However, on the Ford, the system became a major headache. Software glitches and integration failures plagued early tests. At one point, only 2 of 11 elevators were operational, crippling the carrier's ability to rearm its squadrons. Aboard the Kennedy, the Navy expects those lessons to pay off. Structural frames have been reinforced, control systems optimized, and the entire design integrated from the very start, not patched in after construction. Technically, each elevator can reach speeds of about 150 feet per minute and carry payloads up to 24,000 pounds, enough to lift nearly any modern munition to the deck in minutes. If it performs as intended, the Kennedy will sustain a faster sortie tempo, keeping its air wing armed, fueled, and ready. A seamless engine of combat at sea. At first, the Ford-class carriers were equipped with the dual-band radar. It was hailed as a leap in integrated surveillance, but in practice, DBR revealed its flaws, skyrocketing development costs, a complex architecture, and punishing maintenance demands. On the Kennedy, the Navy made a bold shift. DBR was replaced with the Enterprise Air Surveillance Radar, a modular system that's about $350 million cheaper and far easier to integrate across multiple ship classes, from destroyers to amphibious assault ships. Despite the lower cost, EASR delivers powerful long-range surveillance. It can detect, track, and classify a wide variety of aerial and surface threats with far greater reliability. Its true strength lies in connectivity. Rather than working in isolation, EASR links with satellites, early warning aircraft, reconnaissance drones, and escort ships, building a unified 360-degree battlespace picture. This allows the Kennedy to detect and identify threats from every direction in real time. The decision reflects a new philosophy within the US Navy, not always to chase the most expensive technology, but to prioritize systems that are effective, maintainable, and scalable across the entire fleet. Air wing aboard the Kennedy. A carrier's power isn't just about size or propulsion. Its real strength lies in the air wing it carries. Aboard the Kennedy, every upgrade, from elevators to catapults to radars, serves one goal: to deploy a diverse, flexible, and lethal carrier air wing. In theory, the Kennedy can support up to 100 aircraft if operators squeeze every inch of hangar and deck space. In practice, a Ford-class carrier typically embarks 70 to 90 aircraft. The advantage isn't raw numbers, it's composition, how the Navy configures its forces for tomorrow's fights. The backbone will be the F-35C Lightning II, the carrier-capable 5th-generation stealth fighter. Low observable, advanced avionics, networked data sharing. The F-35C gives a carrier strike group the edge needed to strike well-defended targets. Alongside it flies the A-18E F Super Hornet, the workhorse. Not stealthy, but multi-role, reliable, and adaptable to many missions. Providing electronic attack is the EA-18G Growler. Its job: jam enemy radars, degrade air defenses, and protect the strike package deep inside hostile airspace. For airborne early warning, the Kennedy will operate the E-2D Advanced Hawkeye with its APY-9 radar, capable of tracking hundreds of contacts and feeding critical data to the fleet. For logistics and carrier onboard delivery, the Navy is shifting from the C-2 Greyhound to the CMV-22B Osprey, gaining far greater transport flexibility. For anti-submarine warfare and maritime patrol, the MH-60R/S Seahawk remains a versatile mainstay. The real game changer is MQ-25 Stingray, an unmanned aerial refueler. MQ-25 dramatically extends the combat radius of F-35Cs and Super Hornets. With an unmanned tanker on station, fighters can operate hundreds of miles farther from the carrier. That expands the strike envelope and the carrier strike group's reach. Beyond tanking, the Kennedy may become a testbed for new unmanned combat systems, building on experiments like the X-47B. Weapons and defense. A supercarrier is not just a platform for an air wing, it is a strategic target of the highest value. So the Kennedy is wrapped in layered defenses, designed to counter threats from anti-ship ballistic and hypersonic missiles to cheap kamikaze drones. On the outer ring, the Kennedy fields evolved Sea Sparrow missiles, 2 launchers guarding against incoming cruise missiles and hostile aircraft. Closer in sit rolling airframe missiles, 2 launchers tasked with rapid response against inbound threats. If those layers fail, the last line of defense is 3 CIWS phalanx mounts, 6-barrel Gatling guns that spit thousands of rounds per minute, a steel curtain to shred missiles and drones at point-blank range. Alongside them, the Kennedy carries 4 Mk 38 25mm mounts and 4 M2 Browning .50 caliber heavy machine guns. Weapons tailored for fast attack boats, small surface targets, and miniature drones. Together, these systems form a multi-tiered shield from long range to point blank, protecting the ship and every aircraft on its deck. The technological edge, however, lies in directed energy weapons, notably Helios, Lockheed Martin's shipboard laser. In recent trials, Helios shot down unmanned aerial vehicles and disabled rockets, pointing to a new path for fleet defense. Lasers excel because the cost per shot runs almost negligible. They can fire continuously, so long as power is available. With the vast electrical output of 2 A1B reactors, the Kennedy can run lasers at sustained intensity, something earlier carriers simply could not do. 6th-generation fighters and the future. As early as the 1990s, the United States began laying the groundwork for the next generation of air combat. It was the beginning of the Next Generation Air Dominance Program, NGAD, developed primarily for the Air Force. Officially launched in 2007, NGAD has advanced steadily, experiencing a strategic pause in 2024 due to soaring costs, then a revival in early 2025. A full-scale prototype has already flown, proof that America is moving closer to real-world deployment, with the Air Force reportedly selecting Boeing's F-47 concept in March 2025. For the Navy, the parallel effort, the FA-XX program, is tailored for carrier operations aboard ships like the Kennedy. Its contractor competition between Boeing and Northrop Grumman is expected to conclude as soon as this year. The 6th-generation fighter is designed to surpass the F-35C in every dimension. Stealth taken to new extremes, far more powerful sensors, artificial intelligence acting as a digital co-pilot, seamless teamwork with loyal wingman drones, such as the Collaborative Combat Aircraft, and a far greater combat radius. Most importantly, These aircraft will be built to survive inside the world's most advanced air defenses, facing next-generation threats like China's J-36 and J-50 concepts. But one question remains: will the Kennedy be ready to host them? Technically, it already has the foundations. The EMELS launch system can be tuned for any aircraft, from lightweight UAVs to heavy strike fighters. AAG provides flexible arresting power, adapting to each landing profile, and its twin A-1B nuclear reactors supply the vast electrical reserves needed to power the advanced systems these fighters will carry. Yet integrating a new generation of aircraft goes far beyond launch and recovery. It demands new logistics and infrastructure. Hangars must be expanded for larger airframes, maintenance bays re-equipped for advanced composite materials, technicians retrained for hybrid AI flight systems. Even the supply chains, fuel, munitions, spare parts, must evolve to sustain long-range, high-tempo operations at sea, with upgrades already planned during sea trials in 2026 and 2027. If these challenges are met, the Kennedy could become one of the first carriers on Earth capable of operating 6th-generation fighters, lifting US naval aviation to an entirely new level. As rival nations develop stealth drones, hypersonic weapons, and global satellite surveillance, the fusion of a Ford-class supercarrier with next-generation air power will help the United States maintain its edge well into the middle of the 21st century. Even with the most advanced technology ever built, the Kennedy and the entire Ford class face new and growing challenges. For decades, American carriers were seen as untouchable. That era is fading. The greatest threats now come from anti-ship ballistic missiles and hypersonic weapons. China fields the DF-21D and DF-26, with ranges stretching for thousands of miles. Russia is testing the Zircon, capable of reaching Mach 8, almost impossible to intercept. Weapons like these could endanger an entire carrier strike group. At the same time, cheap suicide drones and swarm tactics are emerging, hundreds of small UAVs attacking at once, overwhelming even multi-layered defenses. The nightmare of saturation is now a real possibility. Global satellite surveillance adds yet another challenge. Hiding a carrier's position grows harder every year, undermining the old doctrine of concealment and maneuver. And then there's cost. A $13 billion warship with annual operating costs in the billions is a staggering investment. If the Kennedy were ever lost in combat, the blow would not only be military, it would be political and financial as well. Even so, the US Navy still sees its supercarriers as the core of American power. With the integration of UAVs, 6th-generation fighters, and directed energy weapons, the Kennedy is more than a target to defend. It is a deterrent, a symbol of reach, resolve, and dominance. The greatest challenge ahead: can the United States sustain the doctrine and deployment needed to keep these floating fortresses as true strategic assets for the next half-century? When she finally enters service, expected in 2027, the Kennedy will stand as a living test. Will the crown of King of the Seas remain intact, or must it now be shared with the new platforms of the 21st century? What do you think about the USS John F. Kennedy? Share your thoughts in the comments below. Thanks for watching. See you next time.